Hi viewers, hope you're fine. It's me, the friend. You're watching CamScope, and the topic to be discussed is reactions of alkyl halide. As we have discussed their preparation, nomenclature, their types, and their activity. Now we are going to discuss the types of reaction they give. First of all, they gave nucleophilic substitution reaction, very important reaction in which we study SN1 reaction, SN2 reaction, and then we talk about beta elimination or elimination reactions in which HX type of molecule is removed from an alkyl halide, from one carbon hydrogen and from the other carbon halogen is removed, and then we will discuss its reactions, Wurtz reaction that gives us alkane, that is used for elongation of carbon chain, and the other one is our halogen, alkyl halides reaction with halogens, in which we get again we get alkanes. The last reaction which we react alkyl halide with sodium lead alloy, that is used to make methyl or ethyl lead compounds, which are used as anti-knocking agents. Here we are going to discuss nucleophilic substitution reactions. The reaction in which a weak nucleophile, usually a hydrogen atom, is replaced by a strong nucleophile is called substitution reaction. You can see a nucleophile is attacking on a substrate molecule having partially positive center or electrophilic center. We get the new product in which nucleophile has replaced leaving group, that is a poor nucleophile. It goes with a lone pair of electron or with the negatively charged or with negative charge. The second, this is our nucleophile and it attacks on substrate. We get the product and the leaving group is obtained. Now we are going to discuss the types, basic terminology that is used for substitution reactions. We must know what is nucleophile, its type, what is electrophile, its types, and then we will discuss leaving group and substrate. First of all, we will discuss leaving group, nucleophile, nucleus lovers, phile mean lover, nucleus lovers. Species rich in electron are called nucleophiles because rich in electron species are always in search of nucleus. Species in search of nucleus, or you can say species in search of nucleus. There are two types of nucleophiles. Nucleophile can be neutral. How neutral? Neutral nucleophiles, or you can say negatively charged nucleophile. Negatively charged nucleophile. There are two types of nucleophiles. First one is neutral and the second one is negatively charged nucleophile. Now we will give some example. Ammonia is a nucleophile without any charge. It is a neutral. Likewise, water is also a neutral nucleophile having lone pair that can attack any substrate. The examples of negatively charged nucleophiles are OH, chloride, or fluoridine, or bromidine, or you can say iodine, or you can say SCN, sulfothiocyanate, or you can say thiocyanate ion, or you can say HS ion, or you can say O-methoxy, or you can say methoxy or ethoxy ions are very good nucleophiles. You can write HSO4 and NH2 negative and NO2 negative. All are very good nucleophiles and they are negatively charged. And now our next topic to be discussed is electrophile. As is evident from the name, electron lovers. Phile mean lovers and electrophile mean electron lovers. They are electron lovers. As far as definition is concerned, we will define electron loving species, or you can say species deficient in electron. Species deficient in electron are called electrophiles, or you can say species in search of electron. Species in search of electron are called electrophiles. There are also two types. You can say partially positively charged partially positively charged, partially positively charged, and positively charged. They have complete positive charge, which are positively charged. You can write examples of this substrate. When alkyl halide or in alkyl halide, halogen molecule is attached with carbon, it is partially positive. This is electrophilic center or an example of electrophile. Positively charged, in which we have NO2 positive, or you can write MCH3 positive or C2H5 positive, or you can write as chloronium, that is used in halogenation of benzene. This strong electrophile attacks the electronic cloud of benzene, or you can say bromonium, that is also responsible for electrophilic substitution in benzene. These are the examples of positively charged electrophiles. Now we will discuss leaving groups. The species which leave the substrate are called leaving groups, They are usually halogens. Halogen atoms. They leave the substrate and are replaced by a strong nucleophile. They go with a lone pair, or negative charge, or negatively charged. As far as substrate is concerned, it is the molecule on which a nucleophile attacks. This is our substrate molecule. On this, a nucleophile attacks, as is evident in this reaction. Nucleophile attacks this electrophilic center, and leaving group is to leave the surface of the molecule. Leaving group leaves with a lone pair of electron, or you can say with negative charge. You can say a substrate is a molecule, the molecule on which a nucleophile attacks. A nucleophile attacks is called a substrate. This is how we can understand the basic terminology. What is nucleophile? How many types of nucleophiles are there? What is electrophile and its type? Positively charged or partially positively charged electrophile. And then leaving groups, they have a lone pair. They have to leave the substrate when a strong nucleophile attacks on a substrate. And lastly, we discuss substrate, the molecule on which a nucleophile attacks, and thereby a halogen atom is removed, or you can say a weak nucleophile is removed. That is now called as leaving group. Thank you for watching. Hope so you must have liked this video. Bye.